So refer to the sheet. Title 3D is now 3D. Very basic sheet on three-dimensional geometry. Simple application of results that you've learned. Let's look at these problems. The first problem of the sheet is about a point A, coordinates 1, minus 2, 3, and there is a line that passes through P, which is 2, minus 3, 5, and this line is equally inclined with the axis, the three axes. That means the direction cos alpha will be equal to cos beta will be equal to cos gamma, so L will be equal to M will be equal to N, right? Or even the direction ratios are the same. A will be equal to B equal to C equal to 1. I can take them as 1 also, direction ratios, right? They are equal. Direction cosines equal means direction ratios equal, and each of the direction ratios could be taken as 1. So there is this line, right? Now, the equation of this line then, with direction ratios I can choose as 1, 1, 1, as x minus 2 by 1 is y plus 3 by 1 is, hello, z minus 5 by 1 is the equation of this line. And for any xyz lying on the line, there will be a value of r, and for different xyz's there will be different r's that will be commensurate with that xyz. Now, any point on the line M could be looked upon as r plus 2, comma, r minus 3, comma, r plus 5 is any point on the line, yes or no? Any point on the line, x will be r plus 2, y will be r minus 3, z will be r plus 5, right? What I want to find is the perpendicular distance of A from this line. AT is what I want to find. Clear? Now, so what is the approach that you would recommend? What would you want to do to find AT? Pythagoras theorem then. Okay, so these are all acceptable things to do. So let me tell you something different then. Now, if M is any point, let me find AM squared. What is AM squared? AM squared is going to be r plus 1 whole square, right? Distance formula plus r minus 1 whole square plus r plus 2 whole square. Yes or no? That's AM squared. Clear? Which is 3r squared plus 4r plus 6. Yes or no? Yes or no? Absolutely. The minimum value of AM squared will be 80 squared. Yes or no? The minimum value of AM squared will be 80 squared. And either you can differentiate, or what you can do is you could write it as 3 into r plus 2 by 3 whole squared, 4 by 3, 6 minus 4 by 3, so plus 14 by 3. Yes or no? Right? And this will always be greater than or equal to 14 by 3. Right? So minimum value of AM squared is 14 by 3. And the minimum value of AM squared is actually 80 squared. That means 80 squared is 14 by 3. 80 will be root 14 by 3. And that happens for, this happens for r equal to minus 2 by 3. This happens for r equal to minus 2 by 3. And when r is minus 2 by 3, then you get x, y, z of t, the foot of the perpendicular from A onto this line. Yes or no? Got me? Can I wipe this off? Sounds all right? Now, there are a pair of lines, say line L1. Hello. X by 1 is y minus 2 by 2 is z plus 3 by 3 is one line. There is another line which is x minus 2 by 2 is y minus 6 by 3 is z minus 3 by 4. These are two lines, L1 and L2. And there is a plane containing these two lines, x minus 2y plus z plus lambda equal to 0. We want to be able to find the value of lambda. Now, one thing, this is very simple because this line is contained in this plane. So any point on this line will lie on this plane. Now, for example, a point on the line is 0, 2, minus 3 is a point on this line, isn't it? If I have a line x minus x1 by a is y minus y1 by b, z minus z1 by c, then x1, y1, z1 is a point on the line, yes or no? So x minus 0, 0, y minus 2, 2, z minus minus 3, minus 3. That means 0, 2 and minus 3 is a point on the line, L1, which must lie on the plane as well. So put x equal to 0, y equal to 2, z equal to minus 3 and solve for lambda. Or look at this line, 2, 6 and 3 is a point on this line, which must also be a point on this plane. Satisfying this, you can also find the value of lambda from there. Or so now in this case, you know, they've given you the equation of the plane in a certain sense. But let's say they ask you to find the equation of the plane containing the lines. Suppose they ask you to, suppose this was not given and they ask you to find the equation of the plane containing these two lines, yes or no, right? Let's seek to find the equation of the plane containing the two lines. Now, one of the things that you could do, and please listen to me, these are basic tenets, and you know, you might just want to take proper cognizance of this. See, in a very general sense, x minus x1 by a is y minus y1 by b is z minus z1 by c, suppose is a line, right? And a plane contain, let me call it a1, b1, c1, say. A plane containing this line will be a plane passing through x1, y1, z1, yes or no? This is a line with direction ratios a1, b1, c1 passing through a point x1, y1, z1. Now if I am talking of a plane containing this line, now, then a plane containing this line must be of the form a into x minus x1 plus some b into y minus y1 plus c into z minus z1 equal to 0 must be a plane containing the line. Yes or no? Where if the line passes through x1, y1, z1, you can see that the plane also passes through x1, y1, z1. Now, the direction ratio of the line is a1, b1, c1, whereas the normal to the plane would be ai cap plus bj cap plus ck cap is a normal to the plane. Yes or no? Right? That means ai plus bj plus ck is a normal to the plane, and a vector along the line would be a1i cap plus b1j cap plus c1k cap, and their dot product must be 0 because this lies along the plane, because this is along the line. This is a normal to the plane, so this dot, this must be 0. That means aa1 plus bb1 plus cc1 must be 0. Yes or no? Do you understand that? And of course, you know, given a line, the plane will not be unique, because given a line, there could be multitudes of planes passing through that. So you cannot find the values of a, b and c uniquely from this. It will give you family of planes, right? Now come back to the problem per se. Can I wipe this off? Now, see, a vector parallel to this line is what? I cap plus 2j cap plus 3k cap is a vector parallel to this line. A vector parallel to this line is what? 2i cap plus 3j cap plus 4k cap is a vector parallel to this line, right? The plane could have been written as a into x minus 0 plus b into y minus 2 plus c into z plus 3 equal to 0 would be the equation of the plane, where ai cap plus bj cap plus ck cap is a normal to the plane. Is a normal to the plane, yes or no? Do you understand this? Now ai plus bj plus ck must be perpendicular to this. Normal to the plane must be perpendicular to any line lying on the plane. This is a vector parallel to the line. So this must be perpendicular to ai plus bj plus ck. So ai plus bj plus ck, ai plus bj plus ck dot this vector must be 0. And the dot product is a plus 2b plus 3c is 0. Right? No. Similarly, ai plus bj plus ck must be perpendicular to this vector also. That means 2a plus 3b plus 4c must be 0. Yes or no? And I can now use the rule of cross multiplication. So a divided by 8 minus 9 minus 1, right, equals minus b divided by 4 minus 6 minus 2, right? See, minus b divided by 4 minus 6 minus 2 is c divided by 3 minus 4 minus 1. So which means a by minus 1 is b by 2 is c by minus 1. That means a is proportional to minus 1, b is proportional to 2, c is proportional to minus 1. That means I could have selected a as minus 1, 2 and minus 1, or any multiple of that could be chosen, isn't it? If I select a, b and c, then k, kb, kc are also fine in this, right? So a could be chosen as minus 1, b could be chosen as 2, c could be chosen as minus 1 to find. So a chosen as minus 1, so that's minus x, b chosen as, so 2 into y minus 2 plus c, which is minus z plus 3 equal to 0. So that gives me minus x plus 2y minus z plus minus 7 is 0. So x minus 2y plus z plus 7 is 0. That gives me the value of lambda. Yes or no? Or what you could have done is, since we are just learning, so just get familiar with all the basic tenets of 3D. I hope all of you understand this. Can I wipe this off? What could have been done is to find ABC, which will give me the normal to the plane. ABC, AI plus BJ plus CK will give me the normal to the plane. See, this is one vector, say A. This is another vector B. And both A and B are parallel to lines L1 and L2. And therefore A and B are parallel to the plane. A and B are parallel to the plane. But what I need is a vector perpendicular to the plane. So a vector perpendicular to the plane, for example, could be A cross B. Could be a vector perpendicular to the plane. And then the components of A cross B would be small a, small b and small c. Giving me the normal to the plane, right? So A cross B is what? A cross B is I cap, J cap, K cap, 1, 2, 3, 2, 3, 4, right? Which is I cap into 8 minus 9 minus 1 minus J cap into 4 minus 6 minus 2 plus K cap into 3 minus 4 minus 1. So which is minus I cap plus 2J cap minus K cap. Yes or no? So A could be chosen as minus 1, B could be chosen as 2, and small c could be chosen as minus 1. So we could have got that, and I could, once I know small a, small b, small c, either I could have written the equation of the line as ax plus b into y minus 2 plus c into z plus 3 equal to 0, or and ABC obtained as minus 1, 2 and minus 1, or I could have written the equation of the plane as a into x minus 2 plus b into y minus 6 plus c into z minus 3 equal to 0. I could have also written the plane as this, because the plane passes through 2, 6 and 3, and ai cap plus bj cap plus ck cap obtained as minus 1, a as minus 1, b as 2 and c as minus 1, which could be plugged into this, either this or this. Both will give me the same equation of the plane containing element. Do you all understand everything that I have said here? No confusion, right? Very good. Now number 3, there is a point, your attention please, hello, there is a point A which is 2, 3, 4, and there is a point B which is 1 comma minus 1 comma 5, and there is this xz plane. This is the xz plane. The xz plane divides, hello, divides the line joining A and B in the ratio lambda is to 1. I need to find the value of lambda, right? Now for all points on the xz plane, what is y? 0, right? So the y coordinate of P will be 0. Y coordinate of P will be 0. I then take recourse to deploying section formula. Y is 0 for this point. That means 0 must be y coordinate of the line joining A and B. 0 means lambda into minus 1 plus 1 into 3 divided by lambda plus 1, isn't it? My2 plus ny1 by m plus n. That's 0. That gives me lambda equal to 3. Y coordinate of P is 0. Gives me lambda equal to 3. Yes or no? Right? Problem number 4. There is a tetrahedron OABC. OABC is a tetrahedron. ABC are points. The point A is A2, 3. The point B is 1B2. The point C is 2, 1C. Oh, sorry. A, B, C are these points. Okay. The centroid of this triangle, G, is 1, 2, 3. We need to find the value of A, B and C. Very simple, right? I told you a little while ago. 1 would be, the x coordinate of the centroid would be, O is the origin, O is the origin, x1 plus x2 plus x3 plus x4, x1 by 4. Yes or no? So that's A plus 1 plus 2 plus 0 by 4. Similarly, the y coordinate of the centroid is going to be 0 plus 2 plus b plus 1 by 4. Similarly, the z coordinate 3 must be 0 plus 3 plus 2 plus c by 4. So you can find the values of A, B and C. And distance of the point ABC from the origin, that's going to be lambda will be root A square plus B square plus C square. That will be root lambda. That will be root lambda. Lambda would be A square plus B square plus C square. Very simple, right? Number 5. In problem number 5, there is a triangle ABC. A has coordinates 3, 2, 0. B has coordinates 5, 3, 2. C has coordinates -9, 6, -3. and there is an internal angle bisector intersecting BC at D, then the direction ratios of the bisector AD, internal angle bisector AD, I want to find the direction ratios of this, right, are -10, lambda and 17 are the direction ratios of AD. I want to be able to find lambda. Yes or no? Now, very simple. Or this is an internal angle bisector. Look, what is this length? What is this distance? 4 plus 1, 5, 4, 9. So 3 units is this distance. What is this distance? 12, 144 plus 16, 69, 13. Is this distance? That means BD is to DC must be also 3 is to 13, yes or no? This must be 3 is to 13. So you can find the x coordinate of D how? 3 into minus 9 plus 13 into 5 divided by 3 plus 13, 16. Yes or no? Similarly, y coordinate of D can be found, z coordinate of D can be found using section formula, right? Yes or no? So you know the x, y, z coordinates of D. The direction ratios would be what? x2 minus x1, y2 minus y1, z2 minus z1 will be the direction ratios of, isn't it, of AD. Given x1, y1, z1, x2, y2, z2, the direction ratios of the line joining these two would be what? x2 minus x1, y2 minus y1, z2 minus z1. So x of D minus 3, y of D minus 2, and z of D minus 0. These would be the direction ratios of AD. Got me? Vertices, problem number 6. If the vertices of triangle ABC, A is 1, 4, 2, B is minus 2, 1, 2, and C is 2, minus 3, 4 are the vertices of triangle ABC, then angle B is what we need to find. Very simple, isn't it? Sides? Dot product. See, what is this vector BC? The vector BC, as you can see, is 4i cap minus 4j cap plus 2k cap. Yes or no? Y2 position vector of C minus position vector of B. So 4i cap minus 4j cap plus 2k cap is the vector BC. What is the vector BA? Final position minus initial position. So that's 3i cap plus 3j cap plus k cap, is it? 3i cap plus 3j cap plus k cap, isn't it? That's the vector BA. The vector BC is 4i cap minus 4j cap plus 2k cap. Find their dot product and see what it is. A is 142. 142. So this will go away. That's a vector BA then, right? And what is BA dot BC? What is BA dot BC? The dot product of these two. 3 into 4 minus 3 into 4, 0. So 0. That means BA must be perpendicular to BC. That means this must be 90 degrees. K must be 2. Right? Number 7. There are two lines, L1, which is x minus 4 by 1 is y plus 3 by minus 4 is z plus 1 by 7, that's L1. And there is another line L2, which is x minus 1 by 2 is y plus 1 by minus 3 is Z plus 10 by 8 is another line. We want to find the distance of the point of intersection of these lines from the origin. That means, apparently these lines intersect. That's why you want to find the distance of the point of intersection from the origin. Apparently these lines are then coplanar lines also, right? So what you do is, in order to find suppose these two lines intersect at some xyz, which satisfies this equation and this equation both, the same xyz. And let's say the xyz that satisfies this equation has this equal to R1 and this equal to R2. Right? Now, the xyz obtained from this equation in terms of R1 is what? 4 plus R1 would be the x coordinate, isn't it? 4 plus R1. The y coordinate would be minus 3 minus 4 R1 would be the y coordinate. Huh? But that was 1 minus x. And then we have minus 1 minus plus 7 R1 would be the xyz coordinates of the point of intersection. In terms of R1, in terms of R2, the same point xyz is what? 1 plus 2 R2 minus 1 minus 3 R2 minus 10 plus 8 R2, right? Now this will also be, this can also be check whether they intersect at all or not. If I can find values of R1 and R2 such that this is equal to this and this is equal to this and this is equal to this, then the two lines intersect. That's another check for intersection of the two lines. Now let me equate the x and y coordinates because they represent the same points, the point of intersection of the two lines. So 4 plus R1 is 1 plus 2 R2, 1, and minus 3 minus 4 R1 is minus 1 minus 3 R2. Can you solve for R1 and R2 and tell me how much it turns out to be? R1 is 1 and R2 is 2. Okay. So that means for R1 is 1 and R2 as 2, this will be equal to this, this will be equal to this. Now, important thing for consistency is that for R1 equal to 1 and R2 equal to 2, these two must also be equal. Are they? See, for R1 equal to 1, this is 6. For R2 equal to 2, 16 minus 10, 6. That means the same pair of R1 which equates x and y also equates z. That means the two lines indeed intersect. However, if I found R1 and R2 which causes x and y to be equal of the 2 points, but the z is not equal for the same R1 R2, that means the two lines don't intersect and they would not be coplanar lines. So this is also a check for intersection of two lines or coplanarity of two lines. If I can find R1 and R2 uniquely, such which causes not only these two to be equal, but the same R1 R2 causes these two to be equal, then the two lines would intersect and would therefore be coplanar. So you can find R1 as 1. So you know the coordinates of this point. You can find the distance of this point from the origin and therefore lambda could be found. Very simple. Hey, now in problem 8, we have a point, we have a triangle ABC. A is minus 1, 1, 1. B is 1, minus 1, 1. C is 1, 1, minus 1. And these points are projected in the xy plane. Hey, if a point xyz is projected in the xy plane, what would its coordinates be? Xy 0, right? So the projection of A in the xy plane is going to be what? Minus 1, 1, 0. The projection of B in the xy plane is going to be 1, minus 1, 0. The projection of C in the xy plane is going to be 1, 1, 0. Right? And I need to find the area of the triangle formed out of these points. This is not important. I can apply the determinant half of x1, y1, 1, x2, y2, 1, x3, y3, 1. That's the area of the triangle, right? So the area of the triangle formed out of these projections is going to be 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1, 1. or its magnitude. This or its magnitude will be the area of the triangle formed out of projections of AB. Do you recall that? Half of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. The area of triangle formed out of 3 points in the xy plane. Right? Very simple, isn't it? Have you found this? How much does it turn out to be? 2 square units? Okay, 2 square units. There is a point A, 157. There is a point B, -3, 1, -1. And there is a plane that bisects the line joining these two. That plane has the equation x plus y plus 2z is lambda is the equation of this plane. I need to find the value of lambda. Very simple. P is the midpoint of AB. So the coordinates of P would be x1 plus x2 by 2. So -2, -1, 6, 3, 6, 3, right? x1 plus x2 by 2, y1 plus y2 by 2. And this point lies on this plane. So you can solve for lambda. P lies on this plane. So put x equal to -1, y equal to 3, z equal to 3 and obtain the required value of lambda. How much? 8. Lambda is 8. Can I wipe this off? Number 10. There is a locus described by x, y, z. X is 5 cos u sin v. Y is 5 cos u cos v. And z is 5 sin u. U and v are parameters. If u and v are parameters, x, y, z would be a moving point. X, y, z would be a moving point. And the locus described by this is at a constant distance lambda from the origin. That means x square plus y square plus z square must be a constant. What would be the locus of a point at a fixed distance from another point? Sphere. That means this x, y, z must constitute a sphere whose center is the origin. That means distance of this x, y, z from the origin must be a constant. That means x square plus y square plus z square should turn out to be a constant. Let's perform a reality check on that. Right? X square plus y square plus z squared, which is square of the distance of this moving point from the origin. So 25 cos square, if I add these two, 25 cos square du, sin square v plus cos square v, that's 1, right? Plus 25 sin squared v. Sin square v plus cos square v, that's 1. And 25 cos square u sin square sin u. Okay, this is how sin square u. All right. So this is 1 and 25 cos square u plus 25 sin square u, that's 25. So that means XYZ describes a sphere with center the origin and radius 5. Radius of that sphere is 5. Right? Number 11. A plane passing through 1, 1, 1. There is a plane that passes through 1, 1, 1. Hey, any plane passing through 1, 1, 1 can be written as A into x minus 1 plus B into y minus 1 plus C into z minus 1 equal to 0 is any plane passing through 1, 1, 1, where ai cap plus bj cap plus ck cap is a normal to the plane. Ai cap plus bj cap plus ck cap is a normal to the plane. Now, and this plane that we are talking of is parallel to a line L1 with direction ratios 1, 0, minus 1. That means a line with direction ratios this would be a line parallel to the vector I cap minus k cap, isn't it? And a line L2 with direction ratios 1, minus 1, 0. These direction ratios means parallel to a vector I cap minus j cap. Yes or no? So the plane is parallel to these lines. The plane is parallel to L1 and L2. That means the plane is parallel to these two vectors. Right? These two vectors are parallel to the plane. That means the normal to the plane will be perpendicular to both these vectors. That means the cross product of these two vectors will give me the normal to the plane. Yes or no? Will give me ai cap plus bj cap plus ck cap. So now if I took the cross product of these two vectors, I get the normal to the plane. How do I take the cross product of these vectors? I cap, j cap, k cap, 1, 0, minus 1, 1, minus 1, 0. This will give me a normal to the plane whose I component, this turns out to be I cap plus j cap plus k cap. Okay. So I cap plus j cap plus k cap minus does not matter. Minus of this. Now if this is a normal, then the minus of this will also be a normal. Right? That means A could be selected as minus 1, B could be minus 1, C could be minus 1, or A could also have been selected as minus of minus 1, minus of minus 1 and minus of minus 1. So A could be equal to B, could be equal to C. Each could be either 1 or minus 1 or 2, or each could be 3 or any lambda. So A equal to B equal to C, as you can see here. Plug in A equal to B equal to C, you get the plane as x plus y plus z equal to 3. Is the plane? Yes or no in the first place? That's the equation of the plane. Now, once I have the equation of the plane set for me, A, B, C are the intercepts of this plane with the x, y and z axis, right? So this plane can be written as x by 3 plus y by 3 plus z by 3 as 1. That's the intercept of the plane. And what is A? The point A very clearly is the x-intercept is going to be 3, 0, 0. Y and z are 0, so x will be 3. The point B would be what? 0, 3, 0. X and z are 0, y will be 3. The y-intercept of the plane. C, 0, 0, 3. X is y is 0, so z will turn out to be 3. Yes or no? These are the x, y intercepts of the plane. Now, so there are these 3 points A, B, C, and there is a point O, which is the origin. I need to find the volume of the tetrahedron OABC. Scalar triple product of OA, OB and OC, right? What would be the vector OA? The vector OA would be position vector of this minus position vector of this, which is 3i cap plus simply 3i cap. What would be the vector OB? 3j cap. What would be the vector OC? 3k cap, right? And the scalar triple product 1/6 of OA, OB, OC or its magnitude will give me the volume of the tetrahedron. Yes or no? Right? Which is 1/6 of this determinant 3, 0, 0, 0, 3, 0, 0, 0, 3, 27 by 6, 9 by 2. 9 by 2 is the volume of the tetrahedron. Is that okay or not okay? Sounds fine? Sounds good? Lambda is 9 according to the problem. Lambda by 2, so lambda is 9. Can I wipe this off? Right? Now a variable plane is at a unit distance from the origin. Now the plane could be looked upon as x by a plus y by b plus z by c equal to 1 is a plane. A00 is the x-intercept, 0b0 is the y-intercept, 00c is the x-intercept of the plane, right? And so very clearly A is A00, the y-intercept 0b0, z-intercept 00c, right? And ABC are parameters, they vary. So that means, but subject to a condition that the distance of this plane from the origin is 1 unit. Such should be A, B and C, right? So this minus 1 equal to 0, its distance from the origin is obtained by plugging in x equal to y equal to 0, take the modulus, divide by coefficient of x squared, coefficient of y squared, right? So 1, the distance from the origin is 1 divided by root 1 by a squared yes or no? That means 1 by a squared plus 1 by b squared plus 1 by c squared is 1. Such must be my parameters, ABC. Now, the centroid of this triangle, the centroid of triangle ABC is XYZ. That's a centroid. So x would be what? x1 plus x2 plus x3 by 3. Y would be y1 plus y2 plus y3 by 3. Z would be z1 plus z2 plus z3 by 3. So x is what? A by 3. X is a by 3. Similarly, y coordinate of the centroid is b by 3. Z coordinate of the centroid is c by 3. You need to find the locus of x, y, z. You want to eliminate a, b, c. Plug in a equal to 3x, b equal to 3y and c equal to 3z in this constraint equation. So 1 by 9x squared plus 1 by 9y squared plus 1 by 9z squared is 1, or 1 by x squared plus 1 by y squared plus 1 by z squared. The surface described, it's a surface described by the centroid of the variable triangle ABC is 1 by x squared plus 1 by y squared plus 1 by z squared equal to 9. Clear? The last problem of the sheet, the last bunch of problems, we have a passage here. And we are given 3 planes. There is a plane x minus y sin xi minus z sin phi is 0. Then there is a plane x sin xi minus y plus z sin theta is 0. That's another plane. And x sin phi plus y sin theta minus z is 0, where theta, phi and xi are positive acute angles. And it's given that the 3 planes, intersect along a line. Now, see, if 2 planes are not parallel, they will intersect along a line. Yes or no? There would always be a line of intersection of 2 planes, right? Can you just come? Hold this. Right. So if 2 planes are not parallel, they will have a line of intersection, right? And if there is a 3rd plane, it may not have the same line of intersection. Let's say it can have this line of intersection with this plane and some other line of intersection with this plane, right? So for 3 planes to have a common line of intersection, there must be a condition. It is 2 planes, if they are not parallel, they will always have a line of intersection. But 3 plane, the 3rd plane need not have the same line of intersection with the other 2 planes, right? Therefore, it's conditional. Please. Thank you. Now these are 3 planes. 1, 2 and 3. And if they have a common line of intersection, if this is the LOI, line of intersection of the 3 planes, of course, one common point of the 3 planes is that they pass through the origin. All of them pass through the origin. But let's exclude the origin, which is a trivial solution to these equations. 0, 0, 0 is a trivial solution to this equation. But some non-zero solution to this equation. Let's say there is a point P which is x, y, and z, which is a point on the line of intersection of the three planes, will satisfy this condition. This x, y, z will satisfy this condition as well as this condition. Now, this effectively boils down to eliminating x, y, z from this. Eliminating x, y, z from these three equations, right? Now, how one theoretically eliminates is, let's say if I divide by z, this will be x by z minus y by z, sine phi minus sine phi is 0. So these two equations could be written in terms of x by z and y by z. I could solve for x by z and y by z from these two equations. And now if I divide by z, I'll have a x by z and y by z, which I've obtained from equations 1 and 2, and I can plug in equation 3, and I would have eliminated x, y, and z. That's how I algebraically eliminate this. Now when I eliminate these, then I get a relationship that would connect the sine theta, sine phi, and sine xi. And the eliminant, it's a standard result, the eliminant of these three is obtained by the determinant formed out of the coefficients of x, y, and z. The determinant formed out of the coefficients is 1 minus sine xi minus sine phi, sine xi minus 1 sine theta, sine phi, sine theta minus 1. When you eliminate x by z and y by z from equations 1, 2, and 3, then this determinant formed out of the coefficients must be 0. This determinant must be 0. That's the eliminant. That's the eliminant. That's how you eliminate x, y, z from three equations that have a common non-trivial solution. A trivial solution to these three equations is x is y is z is 0. That's a trivial solution. But if it has a non-trivial solution other than x is y is z is 0, then this determinant formed out of the coefficients must be 0. The same you could have obtained by eliminating x by z and y by z from 1 and 2 and plugging into 3. You would have got the same output, right? But for the time being, in an organized manner, this is how you eliminate x, y, z from these three equations. Got me? Have you simplified this? How much does it turn out to be? Okay. Sine square theta plus sine square phi plus xi is? Okay. Equal to 1. Alright, so this is the condition so that the three planes intersect along a line. There are non-trivial solutions of 1, 2, and 3. Okay, that's part 1 of the problem. Then, now, if they intersect along a line, that means if this condition holds good, then is there a relationship that would connect theta, phi, and xi? Theta, phi, and xi. Okay, so now a long forgotten saga, trigonometry, right? So let me migrate from three-dimensional geometry to trigonometry for a transient period. This is the condition that I have, right? And from this, I want to explore finding theta plus phi plus xi, right? Values. Yes, for sure that will work. But let's learn some mathematics and add values rather than plugging in values, right? Okay, we'll add value right now. We'll not plug in values. Okay, one thing, prima facie, do you see that I could have written this as a quadratic in sine theta? Sine square theta, then coefficient of sine theta, 2 sine phi sine xi, and then sine square phi minus 1 is the constant term equal to 0. Yes or no? Can I write this as a quadratic in sine theta? See, sine square theta plus 2 sine phi sine xi sine theta plus sine square phi plus sine square xi minus 1 equal to 0. Do you realize it's a quadratic in sine theta? Yes or no? What did Sridharacharya teach us? Solution to the quadratic, right? I mean, why I would not deal with discriminant is because I want to retain sine theta here. If I talk of discriminant, that means I'm talking of phi and xi only, right? So let me solve sine theta. But then given that sine theta is positive, given that theta, phi, xi are all acute, the plus minus root b square minus 4ac, the minus gets ruled out, right? Sine theta is minus b phi plus root 4 sine squared xi sine squared phi minus minus 1. Yes or no? By 2a minus b plus minus root b squared minus 4ac by 2a. Yes or no? This, right? Let me simplify matters here. Sine square phi, sine square xi, etc. This one, and see what happens separately. Right? Now I combine this and this. I take sine square phi common from this. Then sine square xi minus 1 is minus cos square xi. Yes or no? Sine square phi, sine square xi minus 1 is cos square xi. And this is minus cos square xi. Isn't it? Sine square xi minus 1 is minus cos square xi. So plus cos square xi. Right? Then this, if I took cos square xi common, then 1 minus sine square phi, which is cos square phi. Yes or no? This then square root is going to be cos phi cos xi minus sine phi sine xi. Yes or no? Cos A cos B minus sine A sine B. Sine theta is cos of phi plus xi. Done. Sine theta is cos 90 minus theta. So this will be equal to this. So phi plus xi is 90 minus theta. Theta plus phi plus xi is 90 degrees. Yes or no? So far so good, right? Now 15. If they intersect in a line, which is required, theta plus phi plus xi must be 90 degrees. If they intersect along a line, what's the equation of the line? Now I want to find the equation of the line along which they intersect. These three planes intersect. Clear? Okay. Now, very clearly, a point through which the line passes is 0, 0, 0, right? So, the common line must be of the form, say, x by L is, say, y by m is z by n kind of a thing. Z, x minus 0 by L, y minus 0 by m. Where Li plus mj plus nk is a vector parallel to the line and therefore lying along this plane. What's a normal to this plane? I cap minus sine phi j cap minus sine xi j cap minus sine phi k cap is a normal to this plane, right? A vector along this line is what? Li cap plus mj cap plus nk cap is along the lines, therefore along the plane. This is along the plane and this is perpendicular to the plane, so their dot product must be 0, yes or no? Their dot product is 0 means L minus m sine xi minus n sine phi, that must be 0, yes or no? Right? Similarly, Li plus mj plus nk will also be perpendicular to sine xi I cap minus j cap plus sine theta k cap, yes or no? Right? So this dot sine xi I cap minus j cap plus sine theta k cap must be 0, right? So I end up getting L sine xi minus m plus n sine theta is 0, yes or no? Bless you. Now I can use the rule of cross multiplication. So L divided by minus sine xi sine theta, see, minus sine xi sine theta plus sine phi equals minus m divided by sine theta plus sine phi sine xi, right? Minus m divided by sine theta plus sine phi sine xi equals, I could have also used a cross product for this, but it's all the same, is n divided by minus 1 plus sine square xi. Wait, same thing. Right? So I can replace L by this number, m by minus of this number, n by this number, and this is obviously minus cos square xi. Now, what about this? Theta is 90 minus phi plus xi. So this will be cos of phi plus xi. Cos A cos B minus sin A sin B will get cancelled with this. So this will simply give me cos phi cos xi. This will simply give me cos phi cos xi. Right? Yes or no? Now let me look at this. Sin phi is cos xi plus theta, therefore. I hope you realize that was sin phi, right? That was sin phi, which is sin 90 minus this, which is cos of this, right? And again, look at this. Cos A cos B minus sin A sin B. Have I made a mistake? This will be minus, right? Yeah, there was a minus here. Minus, right? So then minus sin plus sin will get cancelled. This will give me cos xi cos theta. Cos xi cos theta is what I'll get. Minus cos xi cos theta. The minus taken care of from all sides. Cos xi is not 0, so this will get cancelled. So L could be replaced by cos theta, m by cos phi, n by cos xi. Yes or no? So the equation of the line will be x by L. I can write L as cos theta. Y by M, M as cos phi. Z by N, N as cos psi, etc. Yes or no?